Hello, in this session we are going to look at air conditioning and ventilation systems. Air conditioning systems are systems that cool a space and evacuate tiny droplets of water in the space which the naked eye cannot see, known as moisture. When the air in the space is humid, it carries this moisture in it. So the air conditioning system cools the space and evacuates the moisture accordingly, while ventilation systems are systems that remove the air from a space entirely in order to bring in fresh air. So when a space is filled with odor or moisture, these ventilation systems help in removing that polluted air to bring in newer air. So but that air might come in hot, so it's the work of the air conditioning system now to cool the air. So that's the difference between ventilation system and air conditioning systems. Air conditioning systems cools the air, while ventilation systems removes or brings in new air but does not cool the air. So having said that, air conditioning systems are of various types. We have the compact system. When we say compact system, is a system that combines both the indoor and the outdoor units in one place, which we fondly refer to as window unit. We also have split system, from as the name suggests, split. It means the indoor unit is separate from the outdoor unit. So furthermore, in the split system we have the multi-split system, we have the single split system. The multi-split system is where two or more indoor units are connected to one outdoor unit. When two or more indoor units are connected to one outdoor unit, it's known as a multi-split system, while a single split system is when only one indoor unit is connected to one outdoor unit. So the multi-split system is further classified into standard or ordinary multi-split system, and we also have the VRF or VRV split system. So in order not to overload you with information, I have an image to help us understand. So this is what we call a compact system or a window unit. And I'm sure we all know what they are. This is a multi-split system. You can see here we have three indoor units, ceiling cassettes, not wall hung. They are ceiling cassettes connected to one outdoor unit. Just one outdoor unit is powering these three indoor units. But this multi-split system is not an ordinary split system, it's a VRF VRV system. Like I said, we have the standard split system. This is a single split system. You can see only one indoor unit is connected to one outdoor unit. So, and this indoor unit is a wall hung, not a ceiling cassette. So it can be either wall hung or ceiling cassette. If it's a multi-split system, it can also be either multiple wall hung, or multiple ceiling cassettes, or combined wall hung and ceiling cassettes connected to just one outdoor unit. That is for multi-split system. So having said that, now let's begin placing our ceiling cassette. For the purpose of this training, we are going to be using the multi-space system and single space system for the various spaces we have. So like for this staff room, I'm going to be used as ceiling cassette. Why? Because a ceiling cassette is located in the ceiling, so and it is preferably used in long spaces for efficient and equal air distribution. If you use a wall hung will just focus on just one area, even though eventually the air will be distributed in the space, but a ceiling cassette will be more efficient. So, but it's your choice. If you prefer to use a wall hung, you can of course do that. So now for this space, you can see it's very long, so I think 3 ceiling cassettes will fit into this space. So as usual, we are going to place the components, then we subsequently carry out the calculations in order to size them properly. So now for this, let's use our array tool to place this ceiling cassette, but let's measure the breadth of this staff room. $6,600. Okay, so since we are suggesting 3 rows of a ceiling cassette, of this ceiling cassette, we are going to divide 6,600 by 3. $2,200. So that will be the distance between the ceiling cassettes. So we are going to use a rectangular array, not a polar array. So for the column, it's going to be just 1 column, while for the rows, yes, 3 rows, and the distance between them is 2,200. Okay, so here they are. So let's get the center of this staff room in order to place our ceiling cassettes, to decentralize our ceiling cassette. Alright, so now let's this is the ceiling cassette, these are the ceiling cassettes, sorry, while this is the outdoor unit known as the condenser. So now this pink, yellow and brown pipes are, for this pink, this is a supply pipe. It brings in the refrigerant to the indoor unit so as to evacuate the hot air, while this is a return pipe. It carries back the remaining refrigerant to the condenser. It carries it back to the condenser, known as return pipe, while this brown pipe is the pipe that collects the waste water. Remember, we said air conditioning systems also evacuate moisture. Moisture are tiny droplets of water. So this water now will be collected in these indoor units in a gaseous state. When they come in contact with the cold refrigerant, they will of course turn back to liquid. So now this liquid will be evacuated out of this indoor unit through this brown pipe as a wastewater, and this is the drain line that will take the water out of the building. That is why when we on our air conditioning systems, we see water dripping from the system. So it is as a result of evacuating the moisture in this space, that you see the water going out. It's not the refrigerant that is melting, it's the water being collected from this space. It will accumulate and form lots of water and taken out of the building. So this water is not expected to go into the condenser, and that is why you can see this pipe is terminating here. It's taking it out of the building entirely, not back into the condenser, while this yellow pipe is returning the remaining refrigerant back to the condenser, and then the process starts all over again. I believe we all know air conditioning and refrigeration cycle. So now let's connect our pipes. I'm using my extend tool. I believe you know what I'm doing. Alright, so let's use our trim tool. So this okay, sorry, it's not trimming. Why? Because this is an array, we have to explode it. Alright, so let's use our trim tool again. Yes, so you can see this condensate pipe is connecting to this condensate pipe. That is what we want to achieve. Yes, and yes, so the return pipe connecting to this return pipe, and the supply pipe connecting to this supply pipe. As for that cassette, now for this cassette we'll do the same. Alright, and here too. Alright, so that's that for this space. Now let's move to the next space. What just happened? Okay, let's copy everything. I want the pipes to come along. Okay, I wanted to use array for this space as well, but it seems okay, let's leave it as it is for now. After our calculation, we can still adjust the arrangement if we feel it's not okay, but for now I think it's pleasing to the eyes. And we can just copy this with this reference point, paste it. Alright, so oh, there's difference between the size of this conference room and our staff room. You can see it's coming down a bit, so what we can just take them up. So you can see even from the mail look at this, it's not centralized, so we will still need to make some minor adjustments, but for now let's leave it as it is. After the calculation we can do that. I don't want this to be crossing the window. Yes. Okay, let me still take it a bit further. Alright, so that's that for our multi-split ceiling cassette. Now for this office we can use a wall hung, since yeah, we can use a wall hung for this office since it's a small office. So let's get a wall hung from one of my previous designs. Copy to clipboard. So this is a single split wall hung unit. It is single split. Why? Because it's just one indoor unit connected to one outdoor unit. This represents the condenser, which is the outdoor unit. Alright, so let's see if we can copy this as it is to this office. Alright, yes, I think it's okay. So now the next thing we're going to do is to bring in our extractor fan for our toilets. An extractor fan is a part of a ventilation system, it's a component of ventilation system, and I told you what a ventilation system means. You know, this is a toilet, so definitely there is going to be odor and of course maybe moisture. So this extractor fan will evacuate the air and allow new air to come into these toilets, fresh air to come into the toilets. So let's get our extractor fan. Yes. Do we need this level? Okay, let's just bring it. When we do the calculation, we can size it, we can resize. For now, let it be there so that we don't even have to start typing all over. All we need to do is just to edit. So let's copy this extractor fan to the remaining toilets. So the extractor fan removes air to allow new air, fresh air to come into the space through windows or ventilation fan. Ventilation fan brings in air, it doesn't remove, it brings in air, while extractor fan removes air. So since we have windows in the toilets, we don't need ventilation fan. Once the extractor fan removes the polluted air, the window will allow new air, fresh air to come in, and even through these doors and so on. So let's copy this to our first floor. Alright, so I think everything is in place now. We have our extractor fans, we have our air conditioning systems in place. The next thing now is to carry out the calculations. So let's start with the conference room. This is the conference room. Let's get the floor area of this conference room. Remember how to get your area. So the floor area is 37.13 meters squared. So let's go to our calculation page. Let's copy this to our calculation page. We don't need to be typing afresh. We'll just be editing this previous work I did. So let's get our data. Floor area 37.13, round up, right, meters squared. So now we've gotten our floor area. We want to get our let's get the length and width of our conference room, so that we will be able to compute for our wall area. So the length of our conference room is 4,885. That is 4.9. Let's round it to 4.9 meters. Let's get the width. In this case, our width is longer, right? .6 meters. So 4.9 and 7.6. 3.6 meters. Alright, let's get our height also. Alright, now to get our height, we will need to go back to our architectural drawing. Let's hope the architect has included the elevations. I don't think so. You can see we have roof plan, first floor, ground floor plan, site plan, but there is nothing like elevation to give us an idea of the height, and we are going to need that. We are also going to need our window and door schedule, that is the type of materials and also their heights. Let me show you what I'm talking about. So you can see this is a typical architectural drawing. These are the elevations. So let me zoom in well for you to see. So you can see for this door now, you can see the height is 2100. So if you add the height of this door to this 1050, you get the total height of this floor. So in our own case, we don't have this, so we just have to assume. So let's assume a height of 3.5 meters. Alright, in our next session we will continue with our air conditioning system sizing. See you in the next session.